Hi there! In the last video we looked at the very basic elements of writing a Java program. We looked at declaring classes and the content of a main method and printing text to the screen. In this particular video we're going to take a quick look at numeric data and how we can handle that in printing that to the screen, and then we'll take a look at some arithmetic calculations such as addition, subtraction, multiplication, division, and then we'll look at the modulus operator and what that does. Okay, so the best way to understand any of these things is to take a look at an example in TextPad. So we're going to open up TextPad, and in here now we're going to develop a basic class and we're going to play around with some numeric data and see what we can discover. So the first thing I always say when you're writing a Java class is save it before you've even written anything. Again, you'll want to find your Java programming folder, and we're going to call this one numbers.java. Okay, so we start every Java program with a comment. The comment should give the name of the file, numbers.java. We have to give the name of the author, and that's me, F. Sheridan. And we should give the date as well, which is the 10th of October 2013. Again, you might have other information in this comment at the top of a page, but this is all we'll do for now. You start your class as normal, public class numbers, because that's what we've saved it as. Open your curly bracket, remembering to close it also. Inside that then we have our main method, public static void main string args. Again, remembering to close our curly bracket. And then inside our main method is we're going to give our commands. So we looked in the previous example at printing text to the screen. Now we're going to take a look at what happens when we want to print numbers to the screen. So system.out.println is the command for printing to the screen and moving to a new line. Ordinarily we would then open quotation marks and we would print a string of some sort, but now instead we're going to just try printing the number 9. Because I'm printing a number, I don't need the quotation marks. And by not using the quotation marks, I tell Java automatically that this is an actual numeric number that I'm talking about. One that I can add, subtract, multiply, divide, and manipulate in ways. So let's just compile this and see how it works. Tools, external tools, compile Java. If we go Tools, external tools, and run Java application, you'll see it simply prints the number 9. If I go a step further and into my print statement, I add +5. We would think now that what's going to print to the screen is 9 plus 5. But in fact, when we compile this, Tools, External Tools, Compile, and we run it, Tools, External Tools, Run Java Application, we get the number 14. Because by not putting quotation marks around the text, Java assumes it is a numeric value. We've used an arithmetic operator between the two. We've used the plus sign, so it knows it can add these two values and assumes that that's what we want it to do. If we wanted to print 9 plus 5, we would have to enclose those in quotation marks. Again, we'll compile that, Tools, External Tools, Compile, and then we'll run it, Tools, External Tools, Run Java Application. Remembering, of course, that you have to compile every time you make a change. And here you'll see, because we have the quotation marks, we get 9 plus 5. That's all well and good, but now I want to print the sum next to that. So I want to do 9 plus 5, and then I want to print my 14. I want Java to actually add the numbers together. So let's say 9 plus 5 equals, and then we can concatenate onto the end of that string the sum 9 plus 5. But the only way it's going to know the difference between this plus sign here on the 9 plus 5 and the plus sign that's supposed to add that to the string is if we put brackets around 9 plus 5. Okay, so again we're going back to our BOMDAS from when we were in school. Brackets come first. So if we put brackets around this, we're telling Java, do this calculation and then add whatever you get onto the end of this string. So if I compile that again, and a shortcut to compile is Control and number 1 on the keyboard, for those of you who like to use keyboard shortcuts. So if I press Control and 1 on the keyboard, We compile and we get tool completed successfully. And if I press Control and 2 on the keyboard, it runs the application. And you'll see there now I've got 9 plus 5 equals 14. So because I've used the quotation marks around the 9 plus 5, it knows that I want the actual text. I've got my brackets around 9 plus 5 here, so that tells it to add those two numbers. And this plus sign in the middle says to concatenate the two and print them to the screen. Okay, so join the two together and print them. And that's straightforward enough. Now the thing is, it's not a particularly useful program at the moment. Really what we should be doing is we should be using variables to store this data in. Okay, so this particular program only does 9 plus 5, and if I want to change the sum, I have to change this string and I have to change what's going on here in the brackets. If I introduce variables instead, I can then store the data and it makes it easier to change. So we're going to take a look at that now. A variable in programming is just like a storage space. It's a storage space in the computer somewhere that we can store a particular value. Values of lots of different types. In this instance, we're looking at storing whole numbers. When we want to store a value in a variable, we first need to declare the variable. So I'm just going to put a little comment in here that says declare variables. Now, declaring a variable requires two pieces of information. It requires the type of data that you're going to store in the variable, and then a label for the name of that variable. So in this instance, I want a variable that's going to hold a whole number, and in Java that's known as an integer or an int. And I want to store a number, so the sensible label for this would be number 1. That's going to be our storage box for our number 9. Then we want another variable where we can store our number 5. Again, we're dealing with whole numbers, so it's going to be an int, and the label I'm going to give it is number 2. Now the number 1 and the number 2 that I'm declaring here are names that I just chose myself. You'll see other examples that use x and y, num1 and num2, and so on and so forth. You can use whatever makes sense. Just remember, when naming a variable, it has to start, well, it should, for good practice, start with a lowercase letter. It can't start with a number, and we shouldn't have symbols in there either. I think, again, you could have an underscore, but really just avoid the symbols and you'll save yourself a lot of effort. So, two variables here, number 1 and number 2. And then we need to put the values into the variables. So in order to put the values into the variables, we'll have a little comment here, assign values. We take the variable number 1 and we make it equal to the value that we want to put into it. In this instance, our 9. Then we take our number 2 and we make it equal to the value that we want to put in, which is, in this case, number 5. Now what this has done is it's created two storage spaces, it has put two values into them, and it means then when I come down to my print statement, in place of 9, my print statement now becomes number 1, and then we want to print a plus sign, and then we want to print number 2, so we're going to take the contents of number 1 and print a plus sign, and the contents of number 2, and then let's print an equal sign. And then we want number 1 plus number 2, which should give us the total, or the sum of number 1 and number 2. So again, my brackets are going to add number 1 and number 2, and then it's going to print the content of number 1, a plus sign, the content of number 2, an equal sign, and then the total of number 1 plus number 2. So let's put that to the test. Let's compile it again. Control and 1 on the keyboard is your shortcut, and Control and 2 is your shortcut to run. And there we get 9 plus 5 equals 14. So it looks exactly the same way it did when we output the last program. And you might be thinking, well then why bother? And the reason is this. If I decide then I don't want to add 9 and 5, but I want to add 100 and 200, then I just change the values that are assigned to the variables. And that means I don't have to change my print statement at all. So there's less changes to be made. Again, Control and 1 on the keyboard will compile, and Control and 2 will run. And so now I get 100 plus 200 equals 300. So really now, the formula that I have used in my print statement Works for any numbers that I might want to use. What would be even better, and what I suppose a limitation of this program is, that I add number 1 and number 2 and print them, and I don't actually store that value anywhere. So really what I want to do is I want to do this somewhere else, because without storing this it gets printed and then it's lost in space. It's no good to anybody. So let's make another variable. Again, it's going to hold a whole number, and it's going to hold the sum of our two numbers. So sum is a sensible variable name. Again, using a lowercase letter to start. In assigning the value to sum, the value that we want to assign is number 1 plus number 2. And that's going to add those two values and store them in sum. And that means then, where we have our calculations here in our print statement, we can just replace those with sum. So now we're printing number 1 plus number 2 equals sum. And that should give us the same answer again. So again, Control and 1 on your keyboard will compile, and Control and 2 will give us the answer. 100 plus 200 equals 300. And this program again will work for any two numbers. The only thing is, we don't want to just do sums where we're adding two numbers. We're going to want to do other calculations as well. Sometimes you might want to subtract numbers, multiply numbers, divide numbers. So we need to just take a quick look at the different symbols that we use for that in Java programming. So obviously addition is plus, but if we were to change this to work for subtraction, we would put a minus sign. Okay, so that's straightforward enough. Num1 minus num2 equals sum. So let's just compile that, Control and 1, and run it, Control and 2. 100 minus 200 equals minus 100. So you'll see it does negative numbers as well. Addition and subtraction are straightforward. When it comes to multiplication, the symbol that we use in Java is a star. So again, I'll just change out my minus signs for stars. And we Control and 1 to compile, and Control and 2 to run the program. So 100 times 200 is 20,000. Okay, so your multiplication symbol is your star. And finally then, division is a forward slash. So if we wanted to divide the first number by the second number, we use a forward slash. Control and 1 to compile my changes. Remember, it saves automatically when you compile, so you don't need to worry about saving. And Control and 2. So 100 divided by 200 equals 0. Now here you might have expected to get a decimal number, and that's reasonable enough. But it's giving us 0. And the reason for that is we've declared all of these numbers are as integers. Integers are whole numbers. If we want to deal in decimals, we need to change our data type. And the data type we use for storing decimals is double. Now there are a number of data types that will store decimal numbers in Java, but the example that I'm going to use for the most part is double. You can explore the other data types in your own time. So again, now that we've made this simple change, changed our integers to doubles, if we Control and 1 to compile and then Control and 2 to run, you'll see now we have 100.0 divided by 200.0 equals 0.5. Okay, so now it's dealing in decimal numbers. So in summary, when we want to print numbers or indeed the contents of a variable, you don't surround it in quotation marks. The quotation marks only represent the text that you want to print in your print statement. A variable is a storage space in the computer that enables us to store different values for use in the program. In this example, we had number 1, number 2, and sum. When we declare a variable, we need to give a data type and a label for that variable. The label is one that you choose yourself, but you should remember you can't start it with a number. You shouldn't have any spaces. Try not to use symbols in the name because most won't work. And for good practice, start them with a lowercase letter. When we want to store whole numbers, we use the data type integer or int. And when we want to store decimal numbers, we use the data type double. When we want to add, we simply use the addition sign. When we want to subtract, we use the subtraction sign. To multiply, we use an asterisk. And to divide, we use a forward slash. And that's it really. that's all you need to know for dealing with numbers. For now anyway, it's sufficient, and you should be able to do any range of calculations with that. In the next video, we'll take a look at making this even more useful by allowing the user to assign the values to the variables. So take a look at that one.